the written pad from the end. Right? And if we basically think about it, if there is group of ant which primitive and rest the ant is worker, basic principle they use is a cooperation. Use for communication. Communication purpose you require the cooperation, right? This is very important thing. And if you talk about that, the communication, if you talk about the communication, or in detail we can go there. Basically they use the communication. Semiotic is basically use of your symbols for the communication purpose, and this is combination of your biology and semiotics. This means biosemiotic. We in natures, if we think about it, how they people are communicating, then they effectively communicating using certain chemicals. And they use the chemicals for the effective communication. If we talk about bee, if they find it out at the nest, at that moment of time, they are doing the dance in the air to communicate between the other bees, right? Even if we talk about the human, they had a cooperation, but still we didn't find it out any simple algorithm that can be used for such purpose. So this is a basic thing, and they are doing communication using some chemical, right? If we talk about ant colony, it's not like our housing colony type of things. Honestly, if you think about it, the purpose this is to find out the food source. If suppose we think about it, we are living in India, right? And if we had taken our food and due to some issue, food is fallen down, and you had seen the ant had find it out at and majority of ant coming for collecting that food and they happily going to their nest, right? So how exactly they are behaving, we need to understand it. So first of all, the purpose we are understanding, they are finding out the food source. If we assume it that how they discover the foods, assume we are having 6 ants, right? Mm, with note the ant by 1, 2, 3, 4, 5, and 6. So this is first ant, this is second, this is third ant, this is your fourth ant. Just a second, please hold. Hello? અરે હાર્દિકને કીધું 3 વાર મેં કીધું, હું તો લેક્ચરમાં છું. પણ મેં એને 3 વાર કીધું, એ કહે છે મેં 3 વાર મેં ફોન કર્યો એવું જ કહે છે. This is your fifth ant. This is your something 16th. So all are your ants. Assume that path number 6 is being going out of the page. So we cannot find it out. Okay. Even whenever and through the path they just basic chemical which they are going to deposit on the path which they are visiting, right? Even this chemical having one properties. It with time, right? So obviously your ant contact started, so it might be dropping. Ferments. Similarly for second, how much quantity is dropping is not matter. It's been putting the trail from which path had I traveled. So if you want to come back, it can follow its own trail of pheromones and it can come back to its place. I am drawing this pheromones because you people need to understand what exactly happened by this algorithm, right? And assume that this ant had find the food source. Right? It had reached over here, and now it had find the food source. Now definitely it need to come back from where it had started. So what it will do, whatever the pheromones trail it had put throughout the path, it will start traveling on that path. It had kept the trail because it had dropped the chemical whenever he is going to visit certain path. In this pheromone trail, with the help of it, it can come back to its original position, right? In addition to that, again, whenever it's coming back in this path, then also it's been depositing the pheromones throughout the path. Whatever he had went from source to destination, now he's coming from destination to source back. Now, after some time, so if we talk about it, after some time, this ant came and assume that this ant follows randomly any path, right? So we introduce this has been 6 and we introduce more 4 in 7, 8, 9 and 10. These are the 4 more ants, right? So if we can draw over here, suppose one of the ant follow this path, ant number 9. One of the ant follow this path, this is ant number 7. Some might be follow this path. This is ant number 8 and this is following some other path. This is being ant number 10, right? Again, this 4 will do the same procedure to find out the food source. Just a second, please hold. और અમે હું હરપાઈ મળ્યા પછી તો કેમ કરે અર્થ okay, so again they will do the same procedure to find out the food source or the this objective is to find it food source. So again they will travel on same path, right? This is coming back, new ant is also going in this, so it's also going to deposit the pheromones. This also is going to deposit. Now this hunter is coming back, he had found it out the food source, right? After some time we getting this thing. Path the inner one. This has become the path. All the ant will follow the same path. And definitely, how we can find it out all that, because whenever you are all the ant is following this thing, all the ant will deposit the pheromones. Because I told that the chemical have the properties to evaporate with the time. If nobody is again visiting that path, means the pheromones whatever deposit toward the root going to evaporate. Right? So this is the basic thing the ant will finding out from source to this is your food source. Assume that. And this is basically using cooperation for that. And for communication purpose, using this chemical, right? Now this is the basic thing they aren't just doing. Now if we think about some other thing, now we are having ants. Or we can say that this has been pheromone trace and this is your food source. Already this trail are there and these are your ants. Multiple ants are there. I can draw ant like on this only. I can draw exact ant. These are your ants. Okay. Here. Ant. Now consider this has been your pheromone trail from your source to food source, and your aunt are following that path. If some obstacle came in between it, what happened to this path? We consider the scenario, right? If trail. Right? So again, I redrawing it. This is your trail. And if we say that मैंने ऐसी कुछ चीज बीच में रख दी, this is my object, assume that, and because of that this ant जो यहाँ थी वो स्ट्रीट पाथ पे ट्रैवर्स नहीं कर पाएंगे. This is your food source. Right? So what ant will do at this moment of time, because सीधा रास्ता था वो बंद कर दिया है, बीच में एक ऑब्स्टेकल आ गया, एक ऑब्जेक्ट, राइट? एंड नाउ again they want to go to the food sources. So what happen if we again redraw the figure? Then you will find it out what exactly. And this has been your trail, this has been your object. No, ant will follow both the paths. Don't think about it. It will follow this path also. Some ant will follow this, some ant will follow that path. Just a second. We have also go towards the path. इतनी सारी नहीं होगी ants. कुछ ants होंगी, बिकॉज इतनी तो पूरा रूट हो जाएगा. Deal with this. Scratch. Right? The ant will explore this path. In this path, what the letting of the path explore by the ant. Right? They don't know exactly which path is better, which path is not bad. So they initially start exploring the path, because now they need to find it out the new path. Whatever the pheromone trail or whatever the shortest path they already had invented, now there is obstacle in between it. So definitely now we need to find it out the different solution to reach our destination, right? So they started to explore this path, they started to explore this path, right? One by one, the people find it out on this path there is less amount of pheromones, and because this is shortest path, the evaporation rate is slow. Though this has been slow also, but this path is very long, honestly. The evaporation is high. So definitely because the people communicate using that pheromone, that chemical component, right? So obviously shortest path is there and your evaporation rate is same for both of the path. Definitely your shortest path having more time for the evaporation of the pheromones, and because of that all the ant will travel to this path. And now this is your path, exact. And now none of this is going to follow this path. So this is your new invented path from your source to food source. this is the things what we need to use in our algorithm. Basically, they are having certain obstacle, then also they can find it out the smallest path from it, all the possible solution. So now we come to the ant colony optimization. Till this point, this has been inspiration how the ant is working, what exactly they're using for the communication purpose, and all the things. This is basic examples we just brought out. How they explore the path, how exactly all the ants is following the same path. This is all the reason we need to understand before we come to the exact algorithm. Right? So this is first reported in 1992. Between Diego, I think Marco or something. Merico. Exactly didn't remember the name, but it's been Diego Merico or something. This is a person, I think. Assume that this is my correct name. So after this reported this algorithm in 1992, it's become very popular. And if you find it out the application, if you find it out the shortest path in the graphs, it's been having great amount of application. Right? If we assume that we want to apply this thing to find it out the shortest path, how we can apply it? And again we come. This problem. Assume that this has been traveling salesman problem, and you are all are aware about traveling salesman problem we are having in cities. Your salesman visit all the cities with minimum distance. Salesman cannot repeat any of the cities. Means you cannot generate subtours. Subtours means if you talk about subtour, tour has been your complete path from city 1 to city n, right? Subtours means if you started from city 1, you visited city 2 and again coming back to city 1. You cannot do this thing. If you are going to from 1 to 2, 2 to 3, and then 3 to 1, again you are coming back. This is your subtours. You cannot create subtours over here. That's why I'm writing down the exact objective of the traveling salesman problem. Right? So this is the condition. And now we need to solve this problem using colony optimization. Right? So we can write down the things what exactly we can. 1 minute रुकना. इन्वेंटली तो हमने कितना हमने 400 से पता कि पता house. Okay, so our objective is to find it out the shortest path, or we can say that the best route. We need to find it out. So if you design the algorithm, first we need to initialize the best route. And we need to update it, obviously it's not like that. Right, it's not like that. We can finally sorry, right, initialize this thing. Sorry. Values, or you can initialize the 0 also, no issue about it. If you want to define the path, then do whatever you step need to repeat. Now need to place x ends on in cities. We randomly placing x. X is a number, how many ant you are going to place in the cities. This is first step. Then each of this the ant will construct the root in stochastic greedy manner. Stochastic, that's why we're using probability to finding out the city we are going to visit or not. Why greedy we are telling? What do you mean by greedy? It's using nearby information. You had seen your hill climbing problem or similar terrain link. This algorithms you had seen. If I'm not wrong. Such algorithms you have seen. Right? First step is we need to place the ant to the entity. Second is each ant will going to construct its root in the stochastic gradient manner. Then we need to, whatever the root we had initialized, after each of the ant had constructed the root, we need to update our best root. Now, till in this algorithm, whatever our basic objective of this, here we every time talk about the pheromone trail. In our algorithm construction, we never talk about pheromones. Initializing with certain amount of ant to the entities. After that, each and every ant will construct a path. Then after we are telling the among that path, whatever the ant had been constructed, now you are taking the best path from that. So where is pheromones? Because if we are inspiring from that, we need to follow the behavior what ant exactly is doing. So here we are not doing same as we are doing in your original behavior. After discovering of the tour, we are depositing the pheromones to each and every edges of the tour. Pollens, or we can say the chemical. This is for communication. After the tour discovering on each edges. Okay. Now, if you, somebody is talking that how much amount of pheromones I'm going to deposit on each and every edge of the route or of the whatever the path the ant had find. So here we are not considering the distance of the edges, or if we say the one edge as a distance 15, other edge as a 20, 25, 30. All the edges having different right values, but we are depositing the same amount of pheromones on each and every edge. Please understand. Right? So this is the same thing, but this is a bracket where we have written down the information where exactly it need to deposit the pheromones. Right? Now, after this, you need some termination condition. How much number of iteration you want to run this ant colony optimization, or you can find it out some other criteria where you need to stop the algorithm. So that we need to design it out, right? And then again go back to the loop. Okay, so we are going in detail about it, but this is generalized algorithm that we can design for finding out the shortest path for the traveling salesman problem, right? Initially, we started down the algorithm at that moment of time. We talk about that NPR problem, NP complete problem, right? The people are finding out the solution like this, right? What they exactly done. When we are designing the traveling salesman problem that can be solved using ant colony optimization, at that moment of time, we initialize the best route first. Now, this has been repeated step. This loop statement I written as a computer science person, right? Then we are initializing the ant to n different cities. X and N both are dependent on your problem, right? Then after once you're assign X ant to n cities, after that each and every ant will going to construct its own path. Means it again goes to the steps. This assume this has been your n cities. This diagram is your n cities. This has been in your n cities, and now you have deployed certain ants to the city. After that, what will happen? They again start discovering the path, right? So each and every ant will find it out its own route. After that, which condition will come? Now you need to understand which has been the best path among the all the ants. Over here we just had a food source, but now our objective of traveling salesman problem, this is one city, this second, this third, this fourth, fifth, sixth, this six cities, right? Now complete tour means if the ant had started with this path over here, he's visited this cities first, then fifth, then 10th, then sixth, then fourth, then third, then second, and so on. This is a complete one tour. This, if we talk about it and we write it down over here, we can understand. This constructor route means if ant had started, ant started the visit from his first it visit one, then it visited a six, then five, then two, then four, then three. This is complete one tour. This is discovering in this step. Each of the ant will going to construct a route. This is the one route. This is for ant 1. Similarly, we can ant 2, let's construct one route. Then we are having ant 3, it's going to construct another route. Then we are having ant 4, one route. Then we are having ant 5, it's constructed one route. And then we are having ant 6, it's constructed route. Once all the ant had constructed its route, 1, 2, 3, 4, 5, 6 options are there. Then what we are returned it out. We need to update the best route. We need to find out the best solution from the sixth route. Route. Great. So if we decompose the algorithm, we can find it out. Then what we need to do? We need to deposit the pheromones on edges of that route. Suppose this path. Now we need to deposit it. Just a second, I'll call. Hello? So लेक्चर बताओ जी जस्ट एक मिनट बाकी okay I think it's been almost over. We will meet in next lecture where we can explore it more. Thank you.